Hello everyone and welcome to a new lecture. In this video we're going to talk about the chain rule. Okay, so what is the chain rule? Well, if we have f of x to equal to 3, then you know how to find the derivative of this. This is a constant, then the derivative of a constant equals to 0 according to rule number 1. Okay, if we have f of x equaling to 3x to the 2, okay, you know how to find the derivative of that. That will be rule number 3. Okay, basically this equals to 6x. You'll bring the 2 down, multiplied by the constant, it will be 6, and then you'll take away 1 from the power. Okay, you know what to do if I have this, for example, plus or minus 5x. That will be rule number 4. Okay, you'll find the derivative of the first term plus or minus the derivative of the second term. Okay, you know what to do if I have everything multiplied by 2x to the 5. Okay, if I have two functions multiplied by each other, that will be rule number 5. You'll find the derivative of the first function multiplied by the second plus the derivative of the second function multiplied by the first. Okay, you know what to do if I have everything that I have right here over x minus 1. That will be rule number 6. Okay, you will use this rule that I have right here, f prime of x times g of x minus f of x times g prime of x over g of x squared. That will give you f prime of x, or suppose this is h of x, that will give you h prime of x. Okay, however, what do you do if I have everything that I have right here, okay, raised to a power of 2? What do you do? How can you differentiate something like that? This is a composite function. I have this function inside another function. Well, in cases like that, such that we have a composite function, we use the chain rule in order to differentiate it. Okay, so what do I mean by composite function? Well, you know what is a composite function, but just to remind you, suppose I have f of x to equal to square root of x. Okay, and I have g of x to equal to x minus 1. Then f of g of x, and probably you've had that in algebra, so you're going to put g of x inside f of x. So you'll evaluate f of x minus 1, which equals to square root of x minus 1. So as you can see, I have put a function inside another function. It's a composite function. In cases like that, such that we have a composite function, we use the chain rule in order to differentiate it. So how does the chain rule work? Well, basically, it says that if we have h of x, so suppose f of g of x actually equals to h of x. If we have h of x that is a composite of f of g of x, that is a composite function, it is f of g of x. We have g of x inside f of x. Think of this like a baby function inside a mom function. Okay? Then h prime of x, if you want to find the derivative of this function, basically what you're going to do is you will find the derivative of the big function, you'll find the derivative of the mom function, you'll find the derivative of f of g of x, and then you're going to multiply that by g prime of x. You're going to multiply by the derivative of the function that is inside f of x. Okay? That is what you're going to do right here. Okay? So let's repeat it. We have h of x, it equals to f of g of x. It equals to a mom function. Inside it, we have a baby function. This is the baby function. This is the mom function. Okay? If you want to find the derivative of h of x, then h prime of x equals to the derivative of the mom function, the derivative of this one, multiplied by the derivative of the baby function. As simple as that. So for example, right here, I have h of x that equals to the square root of x minus 1. This is the mom function, and this is the baby function. Okay? Then if I want to differentiate this, h prime of x, it will equal to the derivative of the square root of x minus 1 multiplied by the derivative of x minus 1. Okay? So if you have this, and if you don't know how to do the derivative of the square root of x minus 1, basically think of everything that you have right here as one variable. Okay? Think of it as u. U is a variable. So basically, instead of this, we have the square root of u. Okay, you know how to differentiate square root of u. Basically, this is u 1 over 2. Okay, and the derivative of this equals to 1 over 2 multiplied by u raised to a power of minus 1 over 2. The usual business. You'll bring the power down, and then you'll multiply it by whatever you have. However, the power of it has to be 1 less than that. Okay, so it equals to 1 over 2 multiplied by u raised to a power of minus 1 over 2. However, u equals to x minus 1. So you can say that this is equal to 1 over 2 multiplied by x minus 1 raised to a power of minus 1 over 2. That is it. Okay, so that is the derivative of the mom function. So actually, this equals to 1 over 2. I can put this x minus 1 raised to a power of minus 1 over 2 in the denominator. This minus 1 over 2 will be plus 1 over 2. And 1 over 2 actually is the square root. So I can just say this equals to the square root of x minus 1. Okay? So that is the derivative of the mom function. I have to find the derivative of the baby function. The baby function is x minus 1. It is u. Okay? The derivative of u equals to 1. Because the derivative of x minus 1 equals to the derivative of x minus the derivative of 1. It equals to 1. So multiply everything by 1. Okay? So this is this one. This is g prime of x. This is f prime of g of x. This is the derivative of the mom function. This is the derivative of the baby function. Okay? And I found the derivative of the mom function. How? Well, the mom function actually equals to square root of x minus 1. Okay? So I put everything that I have, okay, inside the square root as u, and then I found the derivative of everything. Okay? And we know that u equals to x minus 1. Then the derivative of the mom function equals to 1 over 2 times x minus 1 raised to a power of minus 1 over 2, or 1 over 2 square root of x minus 1. The derivative of the baby function is 1. Multiply them by each other. That will be the chain rule. As simple as that. Okay? So that was the first example. Let me give you another example. Example 2. Suppose I have h of x to equal to x minus 1 raised to a power of 2 over 3. And I want to find h prime of x. Well, I'm going to use the chain rule in order to find h prime of x. Okay? So first of all, let's identify f of x and g of x. Let's identify the mom function and the baby function. Okay? If I have, so this is the mom function. This is the baby function. Okay? F of x equals to x raised to a power of 2 over 3. G of x equals to x minus 1. F of g of x, which equals to h of x, equals to x minus 1 raised to a power of 2 over 3. Okay? That is f of g of x. Then if I want to find h prime of x, basically I'm going to find the derivative of the mom function multiplied by the derivative of the baby function. Okay? The derivative of the baby function, so basically I'm going to bring the power down, okay? And then I'm going to multiply it by whatever I have left. However, I'll take away 1 from the power. So h prime of x actually equals to 2 over 3 multiplied by x minus 1 raised to a power of, so 2 over 3 minus 1 is minus 1 over 3. Okay, if this is too complicated, you can think of x minus 1 as u. Then I will have u raised to a power of 2 over 3. The derivative of this is 2 over 3 multiplied by u raised to a power of minus 1 over 3. U is x minus 1. Then it will be 2 over 3 multiplied by x minus 1 raised to a power of minus 1 over 3. That is the derivative of the mom function. Multiplied by the derivative of the baby function. The derivative of the baby function is just 1. Okay? Therefore, h prime of x actually equals to this. Okay, so let's delete all this and let me give you another example. So, example 3. Suppose I have h of x to equal to x to the 3 minus 4x plus 2 raised to a power of minus 1 over 2. Okay, I have this function and I want to find h prime of x. Okay, so h prime of x actually equals to, so first of all, identify f of x and identify g of x. This big function is f of x. The little function inside it is g of x. Okay, so f of x actually equals to x raised to a power of minus 1 over 2. G of x equals to x to the 3 minus 4x plus 2. F of g of x will put x to the 3 minus 4x plus 2 inside this function, inside f of x, and it will give us h of x. Okay, so if I want to find h prime of x, I have to find the derivative of the mom function, which is this big function right here, and then multiplied by the derivative of g of x. So the derivative of f g of x multiplied by the derivative of g of x. Okay, the derivative of f of g of x actually equals to, so basically it equals to the derivative of this one. It equals to minus 1 over 2 multiplied by x raised to a power of, or instead of the x we can have u raised to a power of minus 1 over 2 minus 1, which equals to minus 3 over 2. Okay, so actually I'll have minus 1 over 2 right here, and then here I'll have u, or u is x to the 3 minus 4x plus 2. So x to the 3 minus 4x plus 2 raised to a power of minus 1 over 2 minus 1, which equals to minus 3 over 2. Okay, multiplied by the derivative of the baby function. The baby function is x to the 3 minus 4x plus 2. The derivative of x to the 3 is 3x to the 2 minus the derivative of 4x is 4. Okay, this is the derivative of h of x. As simple as that. Okay, you can put this x to the 3 minus 4x plus 2 that is raised to a power of minus 3 over 2 in the denominator. This minus 3 over 2 will be plus 3 over 2, and you can turn it into a root, okay, and so forth. However, this will suffice. So basically, that is the idea, or that is the chain rule. And basically, we use it to differentiate composite functions. If we have h of x that is a composition of f of x and g of x, so we have f of g of x, then if you want to find h prime of x, basically you'll find the derivative of the big function, the derivative of the outside function, the derivative of the mom function, and then multiply that by the derivative of the inside function, the derivative of the baby function, and so forth. Okay, so this is basically the rule. So before I finish the lecture, I want to give you a very useful tool that can help you a lot in practicing and in mastering derivative rules, and that is an online derivative calculator. So if you just go to Google and type in derivative calculator, you'll get a lot of results. However, this is what we want. We want derivative calculator with steps, and basically it is www.derivative-calculator.net. Okay, so click on that. It will take you to an online tool or to an online calculator that can calculate any derivative that you have. Okay, so let's say we have this function f of x equaling to x to the 3 plus 4x minus 5. Okay, and I want to find the derivative of this particular function. Well, all I'm going to do is I'm going to put that into the slot, hit go, and it will give me the derivative of that particular function. Okay, as you can see, this was my input, x to the 3 plus 4x minus 5, and this is the derivative of the function. If I don't know how we got there, I can hit show the steps, and it will give me the steps the calculator took in order to reach that conclusion. Okay, as you can see, these are the steps. Basically, all it did was to find the derivative of each of those terms and then put back the plus or minus in between them. Okay, even if you hit on here, okay, it will show you the rule that is used in order to differentiate this function. Okay, as you can see, it says that differentiation is linear. We can differentiate summands separately and pull out constant factors. Okay, so I'm giving you this tool because if you use this tool, then you have an infinite number of practice problems. Okay, you can just plug in any function that you want, or you can plug in functions that are practicing certain rules, let's say the constant rule or the multiple rule or the quotient rule or the chain rule. Plug in examples like that into the slot and try to solve it by yourself. Okay, see if you reach the same conclusion as the calculator does. Okay, practice a lot, and at the end you'll be able to master the derivative rules and differentiation in general. Okay, if you utilize this tool, it could be a very, very useful practice problem tool. Okay, so with this we come to the end of this lecture.